This is R.d.sharma solution class 12 chapter 19. Exercises 19.25 indefinite integrals we are talking about. X square tan inverse x. First function and second function, that is the main key. Now if we take or if we encounter in integration of tan inverse x, that will be an issue. So we'll take tan inverse x as the first function and x square will be our second function. What does it mean? I am applying the formula directly now. Tan inverse x will be the first function. Then it is followed by the integration of x square with dx. Integration of, now inside this integration there will be two terms. First will be the differentiation of tan inverse x, that is the first function, and the integration of the second function, which is x square dx. Now once this is done, these both separate entities will be multiplied and result will be integrated again. So this x square is going to give you x cubed by 3. That's a simple integration. Tan inverse x remains as it is. D by dx, or differentiation of tan inverse x, will be 1 by 1 plus x square. And integration of x square will be x cubed by 3. X cubed by 3 tan inverse x already being done. Now we will deal with x cubed by 1 plus x square, because 1 by 3 I have taken outside now. So this is x cubed divided by 1 plus x square. X cubed can be written as x square into x. 1 plus x square can be taken as t now. Dt by dx will be equal to twice of x. That means dt by 2 will be equals to x dx. So we are actually integrating with respect to dx. So we have got x dx now. We have to deal with x square and 1 plus x square, or we need to replace them. X dx is directly dt by 2, so let me write dt half I am taking outside. X cube we have written as x square and x, so x square is there. X square can be computed or formulated from here. X square will be t minus 1. So let's write t minus 1 here. In the denominator it will be 1 plus x square, that was taken as a t. And this is a very simple integration. Just need to formulate two terms and integrate them separately. This half is already there. So I am here itself combining this 1 by 3 into 1 by 2, that will be 1 by 6. Please remember, I am doing it to explain. You have to do it in different steps. Now this integration separation t by t minus 1 by t. T minus t divided by t is t by t and dt by t. So this t by t, that is 1. Integration of dt will be t. Dt by t will be log modulus of t plus constant of integration. Now the replacement has to be done because t was introduced by s. It's our responsibility to get rid of it. So t is 1 plus x square minus log and modulus of t, which is modulus of 1 plus x square, plus a constant of integration. Now we have 1 by 6 already there because we have integrated x cube by 1 plus x square. This is the result of that one. Half already taken with 1 by 3, 1 by 6 we already got. So x cube by 3 tan inverse x, and all other terms which are coming up will be multiplied by negative 1 by 6. So just multiply everything by negative 1 by 6. This will be plus 1 by 6. Okay. Now you need to separate them out because there will be constant term appearing. What I am trying to suggest is negative 1 by 6 multiplied by 1 plus x square will be negative 1 by 6 minus x square by 6. This negative 1 by 6 can be combined with the constant of integration c, and we can call it as c prime. So remaining is negative x square by 6, this we have taken, and 1 by 6 will come along with this log 1 plus x square. So let's write log modulus of 1 plus x square, and as I was suggesting, negative 1 by 6 along with the constant of integration will form constant of integration, which is c prime. Just tell the examiner that c prime we have taken as c minus 1 by 6. So this is your final result. Alright. Now this is the step-by-step reference of what I just explained. There are certain steps which I didn't use because I was explaining, or I combined, but this is the way to actually solve this question. Now next one seems to be, you might be tempted to multiply e log x with cos x, taking it as a separate term. Sin x with cos x, taking it as a separate term, and dividing and conquering and integrating them separately. But if you know the exponential and the log theory, you know that e to the power log base ex simply is x. This we have already touched upon in detail in our log and exponential discussions. Even if a raised log base ax is there, then also x will come. So don't worry about e raised log x, assume it just to be x. It's x actually. Now we have a sin x multiplied. So every time you have to use this integration sign, I'm just trying to tell you how we can separate them out. Now multiply cos x inside with x and sin x separately, and now deal with them in a separate way. So we have two different terms or two different integrals that needs to be combined later on. One is x cos x, one is sin x cos x. So let's call this x cos x as a and sin x cos x as b. So a is x cos x integration. I'm dealing it with separately. X will be the first term and cos x will be the second term. So integration of cos x now in minus integration of what will be there, d by dx of x, and integration of cos x dx, and the result will be again integrated. Cos x is what? Is simply sin x. So x sin x minus d by dx of x will be 1. Integration of cos x will be sin x. But we have to integrate it again with respect to dx. So integration of sin x will be negative cos x. So minus minus plus, that is why I have written plus cos x. This you have to do in separate steps. I have just combined them because I am explaining how this integration will come out, and then along with the constant of integration. So a is this one, already done. Now coming to this b, which is the second term of this integration. We have sin x cos x, multiply it by half, so you have a 2 inside. So 2 sin x cos x will be sin 2x. So we need to integrate sin 2x now. Integration of sin 2x will be simply minus cos 2x. 2 is already there in the denominator. Then this 2x has to be differentiated and the result will be divided. So we have 2 in the denominator as well. So when you combine this, it will be negative cos 2x by 4. But the thing is, there is no cos 2x or sin 2x term in the question. So we cannot have cos 2x in the answer, because cos 2x can be disintegrated. It can be changed in the form of sin x and cos x. You already know that. So don't keep it like this. Cos 2x is simply 1 minus 2 sin square x. This formula is quite known to us. Cos 2x is 1 minus 2 sin square x. Now divide by 4. Negative is already there. So multiply with negative. Negative 1 by 4 plus 2 sin square x by 4. Now in the previous question I told you that the constant of integration can be combined with any constant which you encounter. Negative 1 by 4, when it combines with a c which came from a, call it as c prime. So now final thing is a plus b. I regarded one as a, second as b. Now let's combine them or add them. So x sin x plus cos x. Now sin square x by 2. So let's write sin square x by 2. And since the c from a and negative 1 by 4 from b, we combine them and we call them as c prime. So this is c minus 1 by 4. This is your final result. Now how to do this? So this is a way you are going to adopt in order to do this progressively in the terms we have just discussed. Next one is x tan inverse x divided by 1 plus x squared to the power 3 by 2. Now mostly in the inverse integration, we try to get rid of this tan inverse. So in order to get rid of tan inverse, we can have x as tan theta. That's very straightforward. So when you take x equals to tan theta, dx by d theta will be what? Sec square theta. That means dx will be equal to sec square theta d theta. And from x equals to tan theta, theta will be equal to tan inverse x. Now we did it because we need some replacement in the later on discussions or final answer. Now let's come to the integration now. Now x was taken as tan theta, write tan theta here. Tan inverse x, that is tan inverse of tan theta. Now this will give you theta. So it will be theta tan theta. 1 plus x squared to the power 3 by 2. We have to replace dx also. Dx was sec square theta d theta. Then we'll deal with the 1 plus x square to the power 3 by 2. Now 1 plus x square, because x was taken as tan theta, 1 plus tan square theta was what? Sec square theta to the power 3 by 2. Let me tell you and write it. 1 plus tan square theta, because 1 plus tan square theta is simply sec square theta. You already know that. Now it is having a power 3 by 2. Now you know a simple relationship that x to the power a to the power b to the power c all will get multiplied. X to the power a into b. So 2 will be multiplied by 3 by 2. So you have a 3. So sec cube theta you will get. So let's write it in the denominator. Now you need to cancel them out. So sec theta will remain in the denominator. So theta tan theta divided by sec theta, that's what we got. Now tan theta is simply sin theta by cos theta. Sec theta is 1 by cos theta. This goes up, cos theta by 1. This cos gets cancelled. You have a sin theta here. Only sin theta remains. So all this comes down to sin theta. So we have integration of theta sin theta. That is equivalent to integration of x sin x that has been done multiple times in the previous discussions. Alright. But we'll do it here because we are dealing with theta here. And then the final replacements. We'll take first as theta, second as sin theta. So we have a theta here. Integration of this sin theta minus integration of d by d theta of theta and multiplication of sin theta and d theta, this integration of that. And that will be integrated again. Theta, what is sin theta integration? It is negative cos theta. Minus d by d theta of theta is only 1. Sin theta integration is again negative cos theta. So let's deal with negative here itself. Let's make it positive. Integration of cos theta is simply sin theta. So write sin theta here plus constant of integration. Now we have arrived at the final answer, but we need to do all the replacements because theta was introduced by us. We need to get rid of it by ourselves. One more thing here is that we are dealing with tan theta and sec theta. We don't want to deal with cos theta and sin theta because cos theta can be written as 1 by sec theta, sin theta can be written as 1 by cosec theta. Now what is sec theta? Sec square theta is 1 plus tan square theta. Sec theta will be under root 1 plus tan square theta. Tan theta is already there. So this sec theta will be under root 1 plus tan square theta, which is 1 plus x square. So sec theta can be written as under root 1 plus x square. Now we need to deal with cosec theta also. Now cosec theta has also a relationship with cot square theta. Cosec square theta is equal to 1 plus cot square theta. You already know that. These are very basics which we learn in 9th and 10th standards. So cosec theta will be equal to under root 1 plus cot square theta. But we have tan theta as x. So we have to convert this cot into tan. If tan is x, cot will be 1 by x. That means cot theta will be simply inversion of the x. So you can write it as under root 1 plus 1 by x square. So this will give you x square plus 1 by x square under root x. 1 plus x square by x square. Actually it's x square plus 1 by x square under root. So you will get under root 1 plus x square by x. But we are dealing with 1 by cosec theta. So just invert this. So this has to be written as x by under root 1 plus x square. Now whatever I have told you, I am just replacing here. Integration final result will be something like this. Theta will be equal to negative tan inverse x sec theta was under root 1 plus x square. 1 by cosec theta will be written as x by under root 1 plus x square. X by under root 1 plus x square and plus constant of integration. This is your final integration. So this is your final result, or you can say that this is how you are going to go about it. There are certain explanations which I gave that are very obvious, but if you know it, it's better. Otherwise, just do it on the right hand side to show the examiner. Now sin inverse under root x, cos inverse under root x already been done. Here we have tan inverse under root x. Please remember, if x tan inverse x will come or x tan x will come, you already know how to do that. Let's multiply numerator denominator by under root x. So when we multiply numerator denominator by under root x, we will take root x as a t. So take t equals to under root x. So dt by dx will be equal to 1 by twice of under root x. That differentiation you already know. That means twice of dt corresponds to or equates to dx by under root x. So when we integrate after multiplying numerator denominator by root x, this dx by under root x will give you twice of dt. Now the replacement will be something like this. Root x was taken as t, tan inverse x was taken as tan inverse, and root x was taken as t. Dx by under root x was twice dt. So I am taking 2 outside, writing dt here. So it will be something like x tan inverse x. That means t tan inverse t is simply equal to x tan inverse x. And I already told you that x tan x and x tan inverse x has already been done in the previous question. You need to visit it. So the final result, let me write it. This is just a repeated question. That's why I'm writing the actual result. X tan inverse x was 1 by 2 x plus 1 tan inverse root x minus root x plus constant of integration. Since we have a 2 already outside, multiply this. So integration this inside the square bracket is your final result. Okay, this is the reference in front of you. Alright, I hope you'll be able to do this by yourself. Any problem, let me just know. We can do it again. X cube tan inverse x, this will be done in the later discussion. Till then, thank you so much. Take care of yourself.